Differences in electronegativity determine the polarity of bonds. Using figure 4.6 from the text, we can determine the electronegativity values of atoms engaged in covalent bonding. This slide has a single bond between carbon and nitrogen and a single bond between carbon and oxygen. According to figure 4.6, the electronegativity value of nitrogen is 3.0, that of carbon is 2.5, and that of oxygen is 3.5. Since nitrogen has a higher electronegativity value than carbon, the nitrogen is assigned the partial negative charge, while carbon has the partial positive charge in the carbon-nitrogen bond. Likewise, oxygen has a higher electronegativity than carbon, so it is assigned the partial negative charge, while carbon has the partial positive charge in the carbon-oxygen bond. The atom with the higher electronegativity value will have the partial negative charge. You will need to be able to assign partial charges by using electronegativity values from figure 4.6. We can also rank the separation of charge in the bond or bond polarity based on the difference in electronegativity values. To determine the difference in electronegativity, we always subtract the lower value from the higher value. When we consider the polarity of the carbon-nitrogen bond, the difference in electronegativity between carbon and nitrogen atom is 3.0 minus 2.5, which results in 0.5. Looking at the polarity of the carbon-oxygen single bond, we subtract 2.5 from 3.5, which results in a value of 1. Because the difference in electronegativity values is greater for the carbon-oxygen bond than for the carbon-nitrogen bond, the carbon-oxygen bond is more polar. The greater the difference in electronegativity values between two atoms in a bond, the greater the separation of charge, or the greater the polarity. The chart on this slide gives an estimation of difference in electronegativity and polarity. If the difference in electronegativity between two atoms is between 0 and 0.4, the bond is considered to be nonpolar. This is sometimes called pure covalent. I prefer the term nonpolar since it is more descriptive. There's a typo in this chart. The electronegativity range should read 0.5 to 1.9. This range represents polar covalent bond. The lower end of the bond would be less polar than the higher end of this range. Once the difference in electronegativity is 2.0 and greater, the bond is considered to be ionic. We have oversimplified the difference between ionic and covalent bond in that we consider ionic bonds to occur any time a metal engages in bonding. This is not exactly true, and as you consider differences in electronegativity, you may find that some metals engage in what would be considered to be covalent bonding.